Okay, we did not have enough time yesterday to complete going over this, so that's why you're watching it on video so that you can make sure that your lab sheet is accurate and you are understanding what's happening here. So we had to modify our data a little bit to make sure that it was consistent with what would really happen if the cups weren't releasing the golf balls or flipping over. So the first thing you need to do is make sure that your data shows that as the ramp increased, the average distance also increased, okay? If it doesn't, you need to change or erase. You're welcome to use this data if you want, but that's what you need to show. Then, when you come down to part 3 on the reasoning, as you can see, my hypothesis, I picked 5 centimeter ramp and I thought it would go the longest. Obviously, I knew it wouldn't, but that's what I chose. So I know that mine was not supported based on the data. So then when you do your write-up here, what you want to make sure you are including is that comparison piece so you can show, like if you said you thought the 20 centimeter would go the longest, you were accepted, and so your data would show that. This data right up here could support either way. So as I said right here, the data shows the longest traveled distance was the cup at the 20 centimeter ramp with an average distance of 322.3 centimeters. The 5 centimeter ramp only averaged a distance of 66.3 centimeters. So make sure yours absolutely does not have to say the exact as mine, but it does have to have the same delivery, the same meaning. Okay, again, you can pause this at any time, get caught up, and then continue with the video. So the next thing we're going to do is flip it over. Okay, so when we flip it over, the testable question states, how does the height of the ramp affect the distance the cup travels? So looking at the collected data, so again, our data showed that as the ramp height increased, the cup traveled farther. So that's kind of what we had going on here. When the ramp height was higher, the cup's distance was longer. So that was the pattern that we showed. The traveled cup distance represents the amount of kinetic energy the car, or also known as our little golf ball, had to push the cup. So knowing that that is represented by kinetic energy, it leads to the next question. When comparing the speed of the car as the height of the ramp increased, what would happen to the kinetic energy? Well, the kinetic energy would also increase. When comparing speed of the car as the height of the ramp decreased, what would happen to the kinetic energy? The kinetic energy would also decrease. So make sure you have those down. Again, pause, get it, and then you can continue with the video. So right here, based on the lab activity, how does the speed of the car affect the amount of kinetic energy it has? Well, what you should have been able to get from the data, when you have more speed, you have more kinetic energy, okay? So those kind of go hand in hand. Then the next question, giving you something to kind of think about, knowing that when you have more speed, you have more kinetic energy, why would you want a running start to jump over something? Well, when you're running, you've got more kinetic energy, and using that kinetic energy is going to allow you to jump farther versus from a standing position and just trying to jump. So I hope you all kind of figured that one out. And now we're going to do the graphing part of it. And I'm going to actually do this one with you guys. That way you can, instead of just seeing it done, I want to make sure you understand how it's done. So the first thing we're going to do is give it the title, if you remember. If not, you need to practice. It's the effect of speed of car on the kinetic energy of car. Okay. Yes, you do have to write the whole thing. There's nothing shorting about that. You can't shorten it at all. Okay, so the next thing we're going to do is label the X and Y axis. Our X-axis has the independent variable on it. In this case, it's going to be speed of car. It's measured in meters per second. Kinetic energy goes over here on the Y-axis, measured in joules. Okay, now we can start to label the lines on our graph. Always start in the corner with 0. Looking right here, we have 60. You have a 10 by 10 graph. When you do the division, each line will be labeled by 6. Now, when you get to this one, since the number is below that 10, I would recommend that we just go up by 1 because it will still allow us to use the majority of the graph. Okay, now we're ready to put the data on the graph. So we'll start with our 0, 0. The next one, our speed is 20. The kinetic energy is 1. So I'm going to come over here, and I know 20 goes between the 18 and 24. And I'll just put it up here on the 1. The next one is 30 and 2.25. So go to 30, and then it goes up 2.25, just above the 2. The next one is 40. It goes up to 4. The next one is 50, so past the 48, up to 6.25. And then the last one is your 60 and your 9. So when you connect this one, what you're going to notice on this, we have a curved line. So, and the purpose for that, or the reason it's a curved line, is when speed increases, your kinetic energy goes up twice as much. And you'll see that in the next thing that you guys do when you do the little notes page. Okay, so make sure you have all of this correct in your note, on your sheet, and then glue it into your notebook. You can end this video and go to the one with the graphing practice that the sub will give you. Have a good day.